Right. Hello everyone. I'm trying to go through this particular practical that you guys are having a problem with. So I believe most of you guys are a little bit confused as to what basically went on with this whole class. So the base of this practical is actually just to simulate to you how machine learning exactly works. So in this case, we are trying to do a classification to actually understand which is a more dependable, predictable model. So whenever you're doing any modeling, first you need to be able to have like a test data, right? You need to be able to have a learning algorithm to see what model you can create, and then after that you can actually use unseen data to actually use the model to actually differentiate whether is it exactly correct or not based on the model they have created, right? So in this aspect, what you'll be trying to do is to actually come up with a model, which is what the lab is trying to do. So if you go to the lab here, very straightforward, we can try running this lab. Alright, so first of all, you're just trying to import everything else and reading the files. So if you realize the file in diabetes.csv, it has no headers, right? So the first thing we need to do is to actually define the headers, which you can see here: the number of pregnant, glucose concentration, diastolic BP, triceps, so on and so forth. All this information you should be able to actually understand from this area. So number of times pregnant, glucose concentration, whatsoever. Now you may be wondering exactly what is class. Class is more like a target variable, like an output. So in this case, would be like saying that whether is it really diabetic or not. It's because this is like a test data for us to learn and analyze. So first of all, we create this, we run. Alright, it's going to read the file from this diabetes CSV. After that, we actually have this data frame, and when we create this data frame, it's basically going to create a table for us. This is, I believe, from Panda library, right? So you have number of pregnant, you have glucose concentration, so and so forth. Now you notice there's this 7, 6, 8, and 9 columns. That's because they include 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, because we have a class here. So when you actually do it this way, you run this, you should know that this is the dimension of the table, which is pretty much what you see here. Now when we run this next command, you have to describe what exactly going to do is to actually tell you the few statistical numbers that your data has. So something that I want you guys to take note in this aspect is to understand what is range, right? Because the next question they're going to ask you is various range. So what you can do is to actually identify the first minimum amount as well as the maximum amount. Of course, if you realize the min and max actually differs between different variables, which in these columns, right? So first of all, when you want to do, you need to make sure that you do a df.drop first. Why are we dropping this? It's because we don't want this particular class, right? So we are creating a data frame that drops the particular column. So when we run this, you will probably see that the class column is totally gone. Because what we are trying to do here is that we're trying to derive the actual true or false, right? So this is more like a target, because this is the accurate answer that we know. It's like the answer, the cheat sheet. So you want to try coming out with a predictable model and then compare with this target. So if you see what this target has, let's try running it. It's basically 1s and 0, right? Like I said, it's just telling you the results of whether are they really diabetic or not, right? So same thing, we're gonna make sure that we formulate the data shape. This is the new table format, and then we have the target shape, which is just one column with different values. So we need to first count this. Now why we are counting here, this is to tell us that how many are 0, which is the false, that they don't have diabetic, and 1 assuming that they do have diabetic. And what we do here is that we just need to keep track of the number here. But take note here, the result is actually very biased towards people who are undiabetic, because there are more people in 0, right? 500 in this case. So what is the answer? I leave it to you guys to answer this. Moving on to the next one, step number 4. So when we are trying to create model, we need to give them significant amount of train data, right? So what we're trying to do here is actually come up with a train and also a split test data. So in this case, we're going to do 70% training data, and 30% test to see if the model really makes sense, right? So this command will actually come out with 0.3, which is the test size. So you can run this command over here. And then the next thing we're trying to do is to do a logistics regression. So I wouldn't really explain what exactly logistic regression is because I don't think there's a need. But basically, what it does is to train the data based on this particular algorithm. So from there, we are able to see the testing accuracy is 0.82, so it means 82%. And then we have this confusion matrix, right? So you may be wondering what exactly confusion matrix is. So if we go to the slides, this is a confusion matrix. What you see is like a predicted no, predicted yes, actual no, actual yes, right? I'm not going to stop here. I'm going to carry on a little bit further because I'm going to talk about precision, recall, and F1 score. So what is the difference between precision, recall, and F1 score? So this is the accuracy, right? So we also have precision, we also recall, and F1. I think in the slides itself, Prof may have mentioned this thing to you guys. So precision is like true positive divided by the true positive plus false positive, right? So you get the results from there. Same thing with the recall, same thing. So I found a video that is actually very useful, which I'm going to play it for you, that you guys will actually better understand what the differences between accuracy, precision, and recall actually means.
You have a model, and now you want to judge how well it performs. How do you measure model effectiveness? There are several metrics you could use to judge how good a classification model is, the most common of which are accuracy, precision, and recall. Accuracy measures how much of the data you labeled correctly. That is, accuracy is the ratio of the number labeled correctly over the total number. If you are trying to classify just one thing, e.g. hot dog or not, accuracy can be written as the number of true positives plus the number of true negatives over the number of true positives plus the number of true negatives plus the number of false positives plus the number of false negatives. True positives are examples with a positive label that you labeled positive, e.g. you labeled a hot dog as a hot dog. Similarly, true negatives are examples with a negative label that you labeled as negative. For example, you labeled a cat as not a hot dog. On the other hand, false positives are examples that were negative that you labeled positive. For example, you labeled a cat as a hot dog. How could you? And similarly, false negatives are examples that were positive that you labeled negative, e.g. you labeled a hot dog as not a hot dog. The true or false in true positive, false negative, etc. indicates whether you labeled it correctly or not, and positive or negative is what you labeled it. So to recap, accuracy is just the number of things you correctly labeled as positive and negative divided by the total number of things you labeled. In the case where you are trying to classify a lot of things instead of just one, the overall accuracy is just the number of things you correctly labeled in each category divided by the total number of things you labeled. Precision is a measure that tells you how often that something you label as positive is actually positive. More formally using the notation from earlier, precision is the number of true positives divided by the number of true positives plus the number of false positives. On the other hand, recall is the measure that tells you the percentage of positives you labeled correctly. That is, recall is the number of true positives divided by the number of true positives plus the number of false negatives. The difference between precision and recall is kind of subtle, so let me reiterate. Precision is the number of positive examples you labeled correctly over the total number of times you labeled something positive, whereas recall is the number of positive examples you labeled correctly over the total number of times that they were actually positive. You can think of precision as the proportion of times that when you predict it's positive, it actually turns out to be positive. whereas recall can be thought of as accuracy over the positives. It's the proportion of times you labeled positive correctly over the number of times it was actually positive. In the multi-labeled case, precision and recall are usually applied on a per category basis. That is, if you're trying to guess whether a picture has a cat or dog or other animals, you would get precision and recall for your cats and dogs separately. Then it's just the binary case again. If you want the precision for cats, you take the number of times you guessed correctly that it was a cat, divided by the number of times that you guessed anything was a cat. Similarly, if you want to get recall for cats, you take the number of times you guessed correctly that it was a cat over the total number of times it was actually a cat.
Right, so that basically covers what precision, accuracy, and recall really means. So in the case of F number, F score or F measure, F1, basically it's more of a combination of both, which you can actually check out in this part of the slides, and feel free to actually research more on that to actually understand better. So I think F score is more like a good balance between the precision as well as recall, so it gives you a more reliable number, I would say, in this aspect, right? So going back to our practical, right? So we have this part here. So look at the value for the 1, which assuming is this case, I believe you can answer that question yourself. Moving on to the next part, which is the features of importance here. Now, in this case, what they are showing is the ranking in terms of significance, right? So in this case, it's ascending order. So in this case, what I do want to do is that I want to look for descending order instead, which actually shows me that pedigree, number of pregnancy, BMI, glucose consumption, those are the priority, right? Things that really matters first. So in your code, you probably find an issue where you have to do this portion here, where you add this feature names to numpy. We have to sort the index, and you'll probably see this index accordingly to here. But remember to add this minus sign here to actually change it to descending, because I believe they actually works in a different way. So it's just changing the orders in this number. So in this case, this is the first, second, third, and then fourth, so and so forth. This is like the ranking in terms of the significance. So pedigree plays a very important role, and then number of pi to actually determine whether are you really diabetic or not. But come on, we all know that glucose concentration is a little more reliable number in determining if you are indeed a diabetic, right? Because glucose is like sugar and stuff. So now, do you think that this is reliable? Remember when I talk about the minimum and maximum range? How are you going to actually determine if they are indeed comparable within the same minimum and maximum range? So what happens is that it's not going to give you a very accurate number, because some are 0 to 17, some are 0 to 199, right? So it's like going to exam hall to climb a tree, and your friend has a higher tree, and then you have a even higher tree, or a very short tree. It won't be a good comparable examination here in this aspect, right? So what happens is that we need to make sure that we give them a standard, right? So we want to standardize this using a minimum to a maximum scalar here. So we run this code here. Apply the same logistic regression here. So this part actually makes sure that your codes are within the same scale, and applies it to both. And then we can run this part here, which is actually showing you the significance of each variable in this case. So right now you can see that the values has changed from glucose to BMI, pedigree, so on and so forth. So this sounds a little more explainable and more reliable in this case, right? So this is actually what will actually get you. But then again, in the 2 classes data set, there's chances where you can get unbalanced, right? So remember when we actually screw up, we saw this part where it says there's only 500 for negative, and then they have 268 positive. So what happened here is that it's actually imbalanced here. So what we can do is to make sure that we balance it out by oversampling the data and generate more data to actually make it more fair. So you probably need to run pip install imbalance learn, imp learn, right? If you have any issue, you probably be able to pip install delay that actually solves this, or you could also install a new version of Anaconda. I believe it's hold on, let me see, there's one section here that say that you install a new Anaconda. Actually no, yeah, but I remember you need to install something that is the new version of Anaconda. Maybe you can look into that. Right, so going back to this part, we are oversampling the data, so I can run this part here. Right, so earlier on we see there's like 500 and 278 or 68, right? So now we are making sure that this is the balanced data to do a test. And then we can just continue running this data model. And you can see the accuracy changes. Previously the accuracy was much higher, right? 0.82. But now we're after sampling this data with a more balanced data set, things changed. So of course all the other information will change as well. And you can see that, you know, the results here for F-score is slightly higher, if I'm not wrong. Oh no, it's actually lower, right? So this gives you a more accurate result if you're looking into a more balanced data set. So after you have all this information, you would probably run the number again. Again, remember to add this part here and this part here, and you probably see the new changes. So it seems like the reliability of glucose concentration, BMI, pedigree, so forth stays the same. So that's basically how you actually look in this practical. I hope you guys find this useful. Let me know if you guys have any questions. Of course, I am not a very technical guy, so I wouldn't probably be able to answer you very technical stuff, but this is basically what I understand and hope this helps.